In the name of God, hello dear students, my name is Masoud, I'm a physics teacher. We are in Fairqua's website at your service to explain the whole curriculum of physics grade 12. We try to make the physics easier for you and actually our plan is to, and this is our ultimate goal actually, making the physics easier for you as much as possible. In previous lessons, actually, I told you about I explained the centripetal acceleration. We proved the direction of centripetal acceleration. We talked about the Pythagorean theorem and direction of total acceleration, right? And right now, I'm gonna solve some questions have to do with Pythagorean theorem and inverse of tangent function, right? Question number, so we have a figure. This figure is dedicated for what? This figure is dedicated for question number 1 to 6. From question number 1 to 6, we use this figure. The magnitude of total acceleration is found by, we have two options, either Pythagorean theorem or inverse of tangent function. Actually, inverse of tangent function is used for find the direction. But the question says the magnitude of the total acceleration. The magnitude of a total is found by Pythagorean theorem. So this option is true, Pythagorean. Question number 2. The direction of total acceleration is determined by the Pythagorean theorem or inverse of tangent function. Direction of total acceleration means theta, right? How do you find theta? Theta is equal to, look here, tan inverse. Let's say which one, let's say goes to the numerator, which one goes to the denominator. Based on this figure, I told you can move AC, let's say parallel to itself, and it's lawful in mathematics. It's lawful in vectors, actually. It's one of the properties of vectors. You can move any vector parallel to itself without changing its direction. Let me draw another figure for you. This one is AT, and this is AC. So what did I do? I just moved the AC parallel to itself, and both, let's say I can say two sides of a right triangle are present. I want you to draw the third part, the third side, which is called total acceleration. So this is theta. Theta is the angle between the first vector and the resultant. So theta is equal to tan inverse based on the definition of tan. Tan of any angle is equal to let's say opposite side divided by what? Divided by the adjacent side. Opposite side of the theta is AC. So AC goes to the numerator. Opposite to the adjacent. Adjacent means 80. So this is the theta is called direction. Direction of total acceleration. So direction of total acceleration is found by what? Is found by inverse of tangent function. That's why whenever you hear the word direction, you have to think about the tangent function. So inverse of tangent function is, let's say, correct answer. We have a condition here, question number 3. If AT is equal to AC, look here. If numerator and denominator are equal in magnitude, if AT and AC is equal in magnitude, right? Theta will be what? Theta will be 30 degree, 45 degree, 90 degree, or 180 degree. If AC and AT, let's say, are equal in magnitude, for example, 2 meter per second square divided by 2 meter per second square. So we have theta is equal to tan inverse of 1. And tan inverse of 1 is equal to 45 degree, right? So I want you to, let's say, use a calculator uh, take out the calculator and let's say calculate this term. Tan inverse of number 1 becomes 45 degrees. Question number 4. The direction of total acceleration is determined by what? Angle theta. Direction is, it can be inverse of tangent function. It's right. C, A and B is true. D, Pythagorean theorem. So Pythagorean theorem is not the answer because Pythagorean theorem is used only for what? Is it only for find the magnitude of the total acceleration, not the direction. That's why C is true. Only C. Let me choose only C. Excuse me. I chose A and C together. Let me correct it for you. So only C is true. C means A and B. A and B together. Let's move on to another question, which is question number 5. And question number 5 is a question of national exam. This question is a question of national exam. The direction of total acceleration depends on. The direction of total acceleration means, I told you, direction of total acceleration means theta. By the way, this is the question of national exam. This question is a very accurate question. I can say it's a tricky question, tricky. Believe me, it's a challenge question. Actually, I want you to, let's say, go over it. Don't hurry to answer the question. It says direction of total acceleration. The direction of total acceleration means theta, right? Theta. Depends on what? Theta depends on magnitude of 80 only. Is it possible? Theta, let me write the equation of theta. Theta is equal to tan inverse of AC over 80. AC over 80. Opposite to the adjacent of theta. Right? AC over 80. So is it right that theta depend on only 80? So it can't be. It's not true. B, magnitude of AC. It can't be because it doesn't mention 80. C, A and B. What does it mean? It means magnitude of AC and let's say 80 together. D, direction of AC and 80. So I want to tell you a note, right? I want to tell you a note. Let's say most of the students make a mistake about whenever they, let's say they confront this question. Why? Because whenever they read the question, it says direction of total acceleration. And in the options, let's say we have magnitude. Here we have direction. That's what they, let's say, they are mixed up in this situation. They confuse in this situation and they cannot, let's say, make up, let's say, their mind. They cannot decide the right choice. That's why, and they said, teacher, it says direction of total acceleration. That's why I have to choose the direction of AC and 80. It's wrong. Based on this equation, just write the equation of theta in front of yourself whenever you are in the exam. Just write this equation. Theta is equal to tan inverse AC over 80. So theta means direction of total acceleration. Means theta, right? Theta means direction. This theta depends on what? Depends on AC and 80 in magnitude. We don't have direction here. Only it's a, let's say, it's a nomination. Direction is a naming for theta only. But theta itself depends on magnitude of AC and 80 together, right? Neither the magnitude of AC lonely, nor the magnitude of 80 lonely. So theta depends on magnitude of AC and 80 together. And this is the question of national exam. We have one more question of national exam here, question number 6. Let me read it for you. Which of the following is the correct relation between the tangential acceleration, means 80, and what? And the centripetal acceleration AC. Centripetal acceleration and tangential acceleration. Let me read the equations for you. Theta is equal to tan inverse 80 square over AC, right? Did we have, let's say, this exponent in the, let's say, in the tangent function? So it's strange for us. We haven't encountered this equation, let's say, yet. B, theta is equal to tan inverse AC over 80. Yeah, it's familiar for us. Till now it's true. C is equal to AC, option C. 80 is equal to AC over delta T. So we are not familiar with this equation. We don't accept it. AC is equal to 80 multiplied by R. It's not right. That's why 3 options are wrong. Only 1 option is true. Theta is equal to tan inverse AC over 80, right? AC over 80. And this is the question of national exam too. Cool. Question number 7 is a question of preliminary exam. In preliminary exam, this question, let's say we have encountered this question before. Question number 7, what's the angle between centripetal acceleration, AC? It's a nice question. I love this question. What's the angle between centripetal acceleration and tangential acceleration? What's the angle between AC and AT? Let me jog your memory by drawing a figure for you, right? I'm gonna drawing a figure for you, and after that, I want you to guess the answer. This is AT, and this one is AC. So, what's the relation between AT and AC? Which angle is created between them? This angle is a right angle, right? And right angle, the value of right angle is 90 degree. That's why, which option is true? 0 degree, 45 degree, 90 degree, 180 degree. So 90 degree is true. I love this question. It's a nice question, which is a question of preliminary exam. Let's move on to another question, which is question number, question number 9. Question number 8. Question number 8. Any object moving in a circular path, space. So we have a space here, we have a gap. We have to fill the gap here. Any object moving in a circular path. So what's the complement of this, let's say, text? Any object moving in a circular path, A, has a centripetal acceleration. It's nice, right? Any object moving in a circular track, it picks up centripetal acceleration automatically. B, changes its direction continually. Right, it's true. C, both previous options are correct. Of course, they are correct. D, has an angular acceleration, alpha. So it, let's say, maybe it's in some situation, angular acceleration is present. Only in the case of changing the velocity, changing the magnitude of velocity, alpha, let's say, is created, changing the magnitude of angular speed, actually. But does it mention change in magnitude of angular speed? No, it doesn't mention anything. Just says any object moving in a circular path. Maybe it's created, maybe or not, right? Maybe it's created or not. That's why D, it's not, let's say, it's not true. I can say the answer is C. It has a centripetal acceleration, and because it moves around the circular track, that's why it changes its direction perpetually. Question number 9, for an object moves with a variable speed, you see, variable speed. When the object changes with, moves with a variable speed, means it changes its speed. Maybe it speeds up or slows down around the circular track. Only AC is present. It's wrong. AC is in in all situation of an object moving around the circle, AC is present. It's right. But here it says variable speed. It says only AC is present, so we don't accept it. It's not true. Only AT is existed. AT is existed. Actually, it's not true. I told you whenever the object enters the circular track, AC automatically is created. That's why A and B are not true. See, both components of acceleration, AC and AT, are present. It's right. Neither AC nor AT is existed, and it doesn't make sense. D doesn't make sense. Only C is true. Question number 10. For an object moves with a variable speed, look here. Variable speed, varied speed. It changes its speed, let's say perpetually around the circular track. AT is due to what? Is due to the changing its speed or direction, because it says tangential. That's why tangential speed is due to the change its speed, and AC is due to the changing its direction. AC is due to the change of magnitude of velocity or speed. Magnitude of velocity is equivalent to speed. And AC is due to what? AC is due to a change in direction of that velocity. Number 11, tangential and centripetal acceleration are tangential AT and centripetal AC are what? A, parallel. Is it true? Are they parallel in the same direction? A and B, or perpendicular? I'm sure you know the answer, because AT and AC intersect one another. That's why they can't be parallel, because they intersect one another like this. They intersect. This one's AT and this is AC. That's why they make what? They make a right angle, because they are perpendicular to one another. That's why D is true. Question number 12. All types of acceleration are measured in meter per second square, except for which type of acceleration? I love this question. It's a nice question. All types of accelerations are measured in meter per second square. Means all types of acceleration are linear acceleration, except for one of them. Except for what? Tangential acceleration? No. Centripetal acceleration? No. Angular acceleration? Yes. Negative acceleration? No. So, angular acceleration. Let's move on to question 13. Question number 13. Let me read it for you. We have two more questions. Yeah, we have three more questions. Let me read the question number 13 for you. Question number 13. All types of accelerations are produced by means of what? By means of changing in magnitude of velocity, except for what? So all types of acceleration are created by means of changing magnitude, except for one type, right? Which type is not created by means of changing magnitude? Tangential? No. Tangential is due to the change in magnitude of velocity. Centripetal? Yes, centripetal is not created by changing magnitude. Angular? No. Angular acceleration is due to the change in angular speed. Negative? No. So centripetal acceleration is true. Question number 14. Rad per second square is the unit of which type of acceleration? Rad per second square is it the unit of tangential? No, because tangential speed is the linear acceleration. Tangential acceleration is the linear acceleration. That's why rad, it can't be the unit of this one. Centripetal acceleration, also it's a linear acceleration like tangential, and it's not measured in rad per second square. C, angular acceleration, yes. D, C and D. Actually, C and D, I can say C and D. It says, let me change the options. D, A and B. And it's not true, actually. Only angular acceleration actually is measured in rad per second square. Meter per second square is the unit of which type of acceleration? Meter per second square. Look here. Is it the unit of tangential acceleration? Yes. Is it the unit of centripetal acceleration? Yes, because they belong to linear acceleration. Angular acceleration, no. A and B, yes. A and B is right. Thank you very much, guys, for watching this video. See you next video. Bye-bye.